In problem number 40, we are asked to count the number of ways that 6 married couples, men and women, can sit in a row if men and women alternate. So to do this count, let's draw the seats. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We've got 12 different seats for these 6 couples. Now our first decision is who do we want to put here, a man or a woman? Well, we have two choices, two ways to make that choice. Then once that choice is made, we could put anyone, say we choose a man for the leftmost position. We could choose any one of 6 men, and now we want to alternate, so now we could choose any one of 6 women. Now for the third position, we could choose any one of the 5 remaining men, and the fourth position, any one of the 5 remaining women, and so forth. Any one of the 4 remaining men, any one of the 4 remaining women, 3, 3, 2, 2, 1, 1. So what we're going to have then is 2 ways to make our first decision. Who goes in the left seat, leftmost seat, a man or a woman? Then, once that choice is made, we will have 6, 5, 4, 3, 2, 1, 6 factorial ways to arrange the men or the women, times 6 factorial ways to arrange the man or the woman. Well, this turns out to be 2 times 720 times 720. And when I did that on my calculator, I got 1,036,800 ways of making those seatings. Now, in problem number 42, we are told that a family has 6 members, and we want to count, first of all, how many different ways can exactly 3 of them come to dinner. So why don't we do this? There are 6 members. Why don't we choose any 3 of them to come to dinner? Then there's 3 members remaining, and we want all 3 not to come to dinner. Well, that turns out to be 20. And in the second part, we're asked to make the count of how many ways can 3 or more of these family members come to dinner. So the way I like to approach these problems is to take 3 or more and write it in terms of exactly. So this would be the number of ways we could get 3 or 4 or 5 or 6 members coming to dinner. So let's make this count. First of all, there's 6 members altogether. If we want 3 of them to come to dinner, that means there's 3 left, and we don't want those remaining 3 to come to dinner. Then it's an or, so it's a plus. Now there's 6 members. We want 4 of them. There's 2 remaining. We don't want them to come to dinner, so out of those 2, choose 2. And then there's 6 members. We want to invite 5, and out of the remaining 1, we don't want that person there. And then finally, out of the 6 members, we want all 6 coming to dinner, and there's no one left to choose. So really, our problem is solved right here, and on our calculator, when I did that, I got 42.